as I promised, I will not take a lot of time. So let's start with the with the description of the topic, and the topic of our work. Its project is some small part of the bigger project that is done in Kazan Federal University in collaboration with Innopolis University, a big group, and we actually the result of this is actually development of the Rolingua system that is also include some of the contributions from the research of our group. But our main topic of this talk today, for my goal today, is to present experiment from the assessment of text complexity or readability related to school books in 3 levels. And of course, there is a motivation behind this, like practical approach, practical ideas, practical things implemented in this Rolingua system. And theoretically, of course, there are many things that are already done, and they are useful in different domains, including educational domain for academic text analysis, complexity analysis, and readability analysis, reading comprehension. I will not list all of the applications. It's the goal of our team is to study academic complexity in the text, in academic texts, and to this end, we collected a big corpus. But before that, I'll just discuss readability. It's a well-known idea, coming like maybe for already known for several decades at least. So there is a score that can be assigned to text that defined either on a scale of like from 0 to 100 and more, or from just a grade level. And the goal of the tools for readability analysis is to estimate for each fragment of text, or for the whole book, to estimate this scores, like for which grade of the school it's appropriate. There are many other applications. You can rank, for instance, rank some texts that are official, like speech of presidents from the United States, or some other texts. You can rank them according to this scale. And yeah, one of these, the well-known formula is a Flash Kincaid formula in 2 variants. It has in both variants, in the top 2 formulas, you have 2 parameters. The first parameter is ASL, it's average sentence length, and second parameter is the average syllables per word, or word length. So this formula was adopted by Obruneva for Russian. It has some predictive power. It is used, and it's good to apply. Our group later improved this result because the Obruneva formula was just approximation. We built a new version of this, like trained on a school text corpus. It was collected. I will talk about this a bit later. Of course, there are other many formulas. There are more complicated formulas. It's still an ongoing process. You can also use pre-trained language models to estimate the text readability, and use you can use all kinds of estimators, all kinds of lexical features or syntactical features. There is a bunch of research on this also for Russian. We focus on some simple formula just because, like linear regression, just because we are aimed at some audience in groups of teachers, groups of educators who want to have a simple interpretation of the results of estimation. So for each formula, you get some score, and in order to understand what's happening, you should explain the result, which is not that easy with pre-trained language models or neural networks. This is why we explored a very simple models first. So as I said, this improved version, that we will call F/Kincaid grade with simple, with additional subscript SIS. It's a different coefficients, but the same set of features. Again, two features with different coefficients. And the coefficients were fitted on the school textbooks. But this corpus initially was assembled, and it included the high grade, the school books from high school, like starting from 5th grade till 11th. So its performance on the elementary school is not very good. So later on in the current study, we presented the results for the bigger, trained on the bigger corpus, and also appropriate for elementary school, because this formula is just doesn't work well for elementary school. So the data set here is a new data set collected by a group in Kazan Federal University. It has 154 school books. So you can see the distributions of number of textbooks, number of tokens. And it includes the grades from 2nd till 11th, and the number of subjects, several subjects. So here, just to let you know what is the distribution of subjects among grade levels. So you can see some subjects are actually do not cover the whole range of grades, but it's more or less represented. All the grades represented more or less equally. So then we just analyze the sentence length. So we work with two parameters first, and the next part of the talk will be about the third parameter, that is frequency parameter. So this the first part we analyzed. You can see the clear correlation between the sentence length or average sentence length and the grade level. But take a look at this again, elementary school. So for 2nd, 3rd, and 4th grade, you can see these bar plots are kind of overlapping to each other. And that's actually an issue that we found, that also in properly collected set of school books, this feature is not that predictive, not that good for prediction. The same, maybe even worse, for word length. We calculate word length in symbols, but the same happens if you calculate in syllables. They highly correlate to each other. For this study, we calculated metric, this parameter in terms of symbols. And again, you can see this mixture of 2nd to 4th grade that we consider elementary school, and that's kind of a problem. So the idea is to first try to analyze this, to understand how this problem can be solved. So we tried to build the simple model with two parameters that I already described, and then fit and evaluate it on different subsets of books. So this 2nd to 4th grade, and 5th to 7th, and 8th to 9, and 8th to 11, and then on all the books. So despite that there is improvement over the previous version that is in the last line of the table, you can see that there is a significant improvement in terms of average error, mean average error, and so on. But there is still trouble with this separation of different types of books, different grades that you can see on the scatter plot. Different books, different grade levels are presented with different colors, and on this 2 parameter space, it's hard to distinguish between the different separate books, separate grade levels. So it's a problem for practical application of the formula, and the idea was to try to resolve this somehow, and approached it with adding new feature that might be somehow useful. And the common feature for this is the frequency, which is a very good feature for readability formulas that we explored before in other studies. Then we assembled, we calculated 2 types of frequency. So the first one is based on the special vocabulary that is related to elementary school books. This vocabulary was not assembled on our set of books in the corpus, but it was independently collected and built. So we take these words from the intersection of these different books from the 2nd, 3rd, and 4th grades, and then these words are kind of around 4,000 words. So we selected them using the filtering, using the Julian coefficient. And the feature is just how we calculate the feature. We take the word from our book, like in the test set or in train set, and take a look up in that vocabulary, frequency vocabulary, and then average, of course. And the frequency number 2, that is based on the common lexicon, that is a well-known frequency list assembled, created by Sharov and Leshevskaya. And these 2 features, you can see that they both have this negative correlation coefficients with the number of grade. So this is this table in the bottom of the slide presents the Pearson correlation. And the strength of correlation is not that big. And as you can see later, the frequency feature is actually not that also important for the target problem, not that useful. But for if you try to find the correlation, calculate the correlation between the frequency and the grade level for the range between 2nd and the 11th grade, the correlation is quite big, I would say. Not that strong, but still like minus 0.5. Let's see. Okay, the next step was to model, build a model with these several levels of complexity, several levels of textbooks. So we have range between of the grade level between 2nd and 4th grade, and 5th and 7th, and 8th and 11th, as was before. And here you can see in the table, you can see the MSE and MAE errors again. The point is that there is not that much difference between the frequency contribution, and which is more. What is more interesting here is that the comparison to the model, comparing to the model with 2 parameters, this additional feature doesn't improve performance in terms of the error. So this is just a representation of the coefficients that we derived from our experiments. So this is you can see the first coefficient is a constant, and the constant is that's interesting that this A0 coefficient is somehow adjusted to the mean value of the for the grade for the 2nd, 4th, and the 5 to 7, it's fitted to the mean value of the grade, and the other coefficients are very close to what we expect. And for the global model in the last column, you can see that the coefficients actually very close to what we had before. So this is the formula with 2 parameters is obviously works well, not only for the all grade levels, but also for subsets, sub-ranges, sub-levels of this data set. But for the 3 parameters, we have somewhat different results, and they are not that. Of course, we can report them and say, okay, this is a formula with 3 parameters. You can use this. The point is that maybe it's not that robust. This provides not that robust results. So as a conclusion to this topic, I would to this study, we prepare the following. So the formulas are actually the best for assessing complexity for academic texts for Russian. Right now, maybe there are some better formula in the future or for other languages. Yeah, we recommend to use simplest formula with 2 features, also for distinguishing between the elementary school grades. And yeah, these separate formulas are possible to apply if you have some additional information. So if you already know that this is a school text or fragment of a text, this for the elementary school, so you can use the specific formula. It will give you better results than just bigger regression formula for fitted or trained on the whole textbooks. And yeah, we still believe to this in this frequency dictionary for school books, and that might have different applications, or actually not just improvement of the readability, but the dictionary and frequency dictionary for elementary school texts can have different other applications, a set of applications actually. That's it for my talk. I have some time for questions. I hope you have questions. Just some acknowledgements and yeah, questions.
So I have a question. It's maybe not like entirely about your research, the current research you're describing, but the whole line of research. You're describing the readability formulas which are using the linear combination of 2 or 3 features. Is it I don't know, enough for readability? It seems, for me at least, I have really small input for this area, but it seems that for many of 3 features, they have maybe some not linear elasticity, if we use the term from economics. So maybe the higher values of some feature are not like working the same as lower values. Maybe some non-linearity is presented inside the idea of this readability itself, because when you show the graph with dots for yeah, this one, it seems that there is no linear dependency here, at least for me. Maybe I don't see it due to I don't know, not enough and not enough time to look at it. But how do you think about non-linear formulas?
Yeah, we discussed it with colleagues in our group. First of all, there should be some motivation behind this, some scientific motivation and your idea. I understand your idea that for some borderline values or features there could be not linear dependency at all, but maybe some decay or some should be introduced or something like this. But yeah, and here the clear example that we have, I wouldn't say that there is some linear connection or relation here that you can capture for the elementary school. That is, for me, it's just a different. The problem here is not in the functional form of the model, but maybe in the set of features, and switching to completely different approach may resolve this mess in the elementary school texts. May not, I don't know, but for me it's clear that short sentences with short words may appear in the range of first, second, and fourth grades, of course. Maybe it's just a problem not in the linearity, but in the set of features that should be reconsidered somehow. And of course we played with a lot of features like syntactical features, part of speech, not for this specific corpus, but previously a different corpus. And yeah, there are some features that are useful. The problem that when you increase number of features, this interpretation power decreases. You should somehow explain it in simple words to teachers, educators, I don't know, school teachers, why this and that result. And it's much harder if you have like 10 features with parts of speeches or, I don't know, syntactical dependencies inside the text. And that's kind of trade-off. But linear formula, I think that's the simplest solution, and that's why we pick this and trying to push to a possible limit.
Okay, thank you. It was quite a speech about this question. It was really interesting to see the new results in this area. So thank you, Vladimir, for your talk.
Thank you all.